Hello, unparalleled friends, learners, and creators. My name is Emily Karolidis, and I'm a joint master's PhD student here at the University of Oregon, studying biomechanics and its applications into sport product design. I will be walking you through an introduction to footwear biomechanics, part 2 in our Footwear Creator series. Starting off is a general overview of biomechanics. Biomechanics is an applied science, derived from physics and human physiology. It is a study of the structure, function, and motion of biological systems. The way that those come together is an integral part of the field of biomechanics. Structure is what dictates function. The origin and insertion point of a muscle group, for example, will inform its functionality, or its purpose in the system. When a group of muscles work together, their unique functional capacity will generate human motion, bringing these concepts together. When we study biomechanics in the industry, it's important that we understand the way that the product and user interact. We see this in apparel, footwear, and equipment applications, each serving different, equally important purposes, specific to the job to be done. In footwear biomechanics, we look to improve efficiency. In sports bra biomechanics, we look to reduce the movement of tissue mass. In golf club biomechanics, we look to increase energy transfer from the body in the club to the ball. In football, it's all about protection against impact. Sailing, to increase force generation through the weight of the body, and skiing, to increase velocity or speed. When we hone in on footwear, which has the bigger overall picture of efficiency, footwear biomechanics focuses on several important features: stability, shock absorption, energy return, lightweight, and appropriate traction. Looking at the various types of running shoes, these needs are prioritized differently, depending on the purpose of the shoe. For example, what would a spike be without its excellent grip of the track? Or a trail running shoe without its stability? These problems to be solved are divided into different elements of the shoe. Stability, for one, is often factored in at the upper. Shock absorption, energy return, and the weight of the shoe are all cushioning solutions solved at the midsole. When we look at traction, that's an outsole solution. We will start at the upper. The upper encloses the top part of the foot and can be constructed from a variety of synthetic materials. Different materials will have different properties, which is crucial to the stability of the shoe. If your material choice is too stretchy, your foot will not be locked down at the footbed. If the material is too rigid, your foot will be super uncomfortable. This becomes especially important with running shoes, as they have a raised midsole. The further off the ground you are, the less stable you will become. Medial-lateral stability is a term used to describe any movement of the foot away from the midline. Keeping proper alignment is important for form and injury prevention, such as ankle rolls. Introducing stability at the upper can be done through lacing, appropriate material choice, and fit of the upper pattern. Moving into the midsole, this is the space with the most innovation in the running shoe game: cushioning. The question of how can we get the greatest energy return with the highest shock absorption while being the lightest weight will forever fuel the running industry. Let's start at shock absorption. When we run, the force of impact at our heel and forefoot is estimated to be 3 and 5 times greater than that of our own body weight. That's a lot of impact being compounded at our bones, muscles, and joints. One important job of the midsole is to attenuate or reduce the compressive force felt at our moving parts. The solution? Cushioning. The idea of shock absorption is often balanced with the concept of energy return. This is to maximize the amount of energy generated by the athlete to be transformed into forward movement. We want to prevent lost energy at the foot-ground contact, and the way that we do this is through midsole foam. The better the energy return, the more efficient the athlete can run, which is why this is such a key innovation space for athletic companies. Lastly, the weight of the shoe must be considered. For every 100 grams added to the foot, the cost of running increases by 1%. So optimizing a running shoe midsole is a delicate balance of priorities, so we need to evaluate what the end goal of the shoe is. The outsole is where we'll be wrapping up our footwear exploration. This is the part of the shoe that is the point of contact between the foot and the ground, made of a very thin layer of rubber. This rubberized outsole is responsible for generating the force of friction at the interface of the shoe and the ground. This is what opposes slippage and is known as traction in the field of footwear. Depending on the needs of the sport, traction may need to be very high, like in trail running. We increase traction by increasing our contact surface area, increasing our tread depth, and concentrating our tread designs at areas of high contact. Taking what we now know to be important from a scientific perspective, let's now move on to some applied footwear design. Continue along in our Footwear Creator series to see where we take the innovation process next.